So, good afternoon, everyone. Today, let us try to discuss 24th June. So, today we will try to discuss 24th June 2022 JEE second shift. So, we are trying to make sure that not just the questions but concepts behind them are covered. Because if we try to look at the yesterday paper, we have few concepts that are getting repeated for each session only. So, there is a very good chance that for next season, that is season 2 of JEE 2022, we can expect a good number of concepts and questions from these sets. So take care that you are aware of these concepts and make sure that you don't make any mistake in this. So let's start this session. So before getting into the session, so yesterday we have discussed 24th June JEE, sorry, this is first shift. So this is 24th June first shift that occurred in the morning. Yesterday we discussed 24th June second shift. So now let's get into the session. So people watching online, do open your books, try to solve them, and please get back to me if you have any difficulty and comment your doubts. Okay? So hi Pratik, hi Abhi, come on. Let's try to open your books, try to solve the problem. So today we are doing 24th June first shift that happened early in the morning from 9 to 12, I guess. So if you try to go to the question, so the bulk modulus of the liquid is 3 into 10 power 10 Newton per meter square. The pressure required to reduce the volume of 2% liquid is dash. So the given data, so we know from the formula of bulk modulus, delta P is equal to minus K dV by V. So K is the bulk modulus. We have bulk modulus here, bulk modulus which is K. The pressure required to reduce the volume, that is delta P, is being asked, and delta V by V is given as 2%. So you just substitute them into the formula. What is minus K? Into dV by V. It is given in terms of percentage, so 0.02. See, as the volume is being reduced, dV, V final minus V initial will be negative. So it turns to be minus 0.02. So the final answer you will be getting is 6 into 10 power 8 Newton per meter square. So direct formula substitution, we have bulk modulus K dV by V 2%. As it is being reduced, we get negative sign. So substitute it, we get the pressure required, P, 6 into 10 power 8. So hi Venkatrao. So please share if you have any doubts. So this is about first question. So now let's try to look at, hi Amir Khan. So good morning everyone. So people online. So hi Rahul Karthik, hi Sridhar, come on, try to share your questions. Sorry, try to share your doubts so that we can discuss. We are trying to discuss 24th June first session physics paper. We are not only just trying to discuss the question but also concepts behind them, because questions are being repeated like anything. If you try to look at the second session, we have common questions in both first and second sessions. So make sure that you are good at these concepts and make sure that your doubts get cleared in all these concepts. Okay. So let's try to go for question number 2. It is assertion and reasoning question. The statement 1 says that in an uniform magnetic field, speed and energy remains the same for a moving charged particle. Okay. The reason says that moving charged particle experiences magnetic force perpendicular to its direction of motion. Okay. So what do we know? So from the basic fundamental formula, the force applied on a charge q which is moving in a magnetic field with velocity v is equal to bvq, where q is the charge, v is the velocity of the charged particle, b is the magnetic field. So assertion says that in a uniform magnetic field, the speed and the energy remains same for a moving charged particle. So let us consider this as a magnetic field which is perpendicular and the charge q is moving. So the force on charge will be perpendicular to the direction of motion. Okay. So basically it makes the charged particle to move in circular motion, and that force acts as a centripetal force. Okay. So the magnitude of velocity, the magnitude remains constant. So the magnitude remains constant, but the direction keeps changing. So velocity keeps changing, but the magnitude of velocity remains constant. Okay. So what do we have? Uniform field, its speed is nothing but magnitude, right? So the magnitude remains constant. Energy, what do we have? Kinetic energy is equal to mv square by 2, right? So as v is constant, magnitude is constant, k is also constant. So speed remains constant, energy remains constant. So assertion correct. So the moving charged particle experiences magnetic force perpendicular to its direction of motion. So the force will be in perpendicular to the direction of motion. Correct. And it is also the correct reason, because as the force is perpendicular, the velocity, the magnitude of velocity is not changing. So the speed and energy remains constant. So both assertion correct, reason correct, and is also correct explanation. So assertion and R are true and R is the correct explanation. So come on, hi Ram Pratik, hi Venkatrao, hi Rajeshwar Gaud. So what are your formula for uniformly charged circular ring? So R is equal to radius is equal to mv by bq. So we have one formula, and as said earlier, F is equal to bvq, that is another formula. So we have a couple of formulas we start deriving. So if you can go through the textbook as well. So in this question, if you have any sort of ambiguity or doubt, please get back to me. Okay, Amir Khan, nice. So both A and B are correct, and A is a correct explanation. So let's try to go for next question. Two identical cells, each of EMF 1.5 volts, are connected in parallel. Okay. across a parallel combination of two resistors of resistance 20 ohms. Okay, a voltmeter connected in the circuit measures 1.2 volts, the internal resistance of each cell. Okay, let's try to draw the figure first. So what he's trying to say is that two identical cells, okay, are connected in parallel. Okay, right, they are connected in parallel across a combination of two resistors, each of resistance 20 ohms. A voltmeter is connected in circuit, the internal resistance of each cell. Okay, the resistors are also connected in parallel. Yes, the question is bit. Identical cells are connected in parallel across a parallel combination of two resistors, right? See, cells are connected in parallel. In the similar fashion, resistors are also connected in parallel. Okay, this is what we get. So R1, RR are same. So here he is trying to ask what is the internal resistance for each cell. So this is the notation for ideal cell. Here he is asking the internal resistance. So we cannot show a real cell this way. So the real cell has some internal resistance which looks this way, IR. Internal resistance, okay. ER, okay, you can write it as ER. Okay, let us simply represent it as R. Why not? Why E and I? Okay. This is capital R and that is small r. So this is what being asked, this is what given. So here it is said that a voltmeter is connected in the circuit and measures 1.2 volts. So voltmeter is connected in parallel. So this is only the point where we can connect voltmeter and it shows a reading of 1.2 volts. So the potential difference across the parallel capacitors and parallel cells is 1.2 volts. So if you try to write the equivalent of the circuit, it looks like this. See, so this is what given. So we are trying to write the equivalent circuit. potential meter gives a reading of 1.2 volts. Okay, it is of 1.5 volts. Okay, so first let us find the current. So what is this R equivalent? Is equal to R1 R2 by R1 plus R2, right? 400 by 40 is equal to 10. So R equivalent is equal to 10 ohms. Okay, so let us try to find the current first. So 1.2, the potential difference across the R equivalent is equal to I into R. So I is equal to 0.12 amps, right? So we have people asking that when will key come, for what? So for EAMCET it takes time, and for JEE means we have already key with us. So let's try to discuss the morning shift 24th June. Okay, so we have I, we got I. So even this is R equivalent of internal resistance. So how to solve this? So now we'll try to apply the Kirchhoff law. We got that I is equal to 0.12 amps, right? So the potential difference across these 2 points is also 1.2. So 1.5. So we are starting from here. 1.5 minus I R equivalent is equal to 1.2. Okay, from first circuit, if you try to apply Kirchhoff law. So I R equivalent will be 0.3 by I, right? 0.3 by I. So what is I? 30 by 12. We can write, right? So we have R equivalent. So what is this R equivalent? We have 2 R's, right? So R equivalent is equal to R by 2. If you try to apply 2 resistors are in parallel, so R1 R2 by R1 plus R2, we will be getting R equivalent is equal to R by 2. So which is equal to RA by 2. So 30 by 6. So the internal resistance will be 5. So come on, people watching. Try to share your doubts, answers. Let's try to discuss, okay? Come on. So this is about the question. Hope you are clear with this. First we have drawn the given circuit, we converted it into equivalent circuit. R equivalent, small r equivalent, E remains the same. When connected in parallel, E equivalent will be E. So we try to apply the Ohm's law, V is equal to IR. We found the current, we found the R equivalent and found the current, and we are trying to apply the I for this one, for first circuit. So we get R internal as 5, because R equivalent is equal to R internal by 2. So hope this is clear. Now let's move to next question. Identify the pair of physical quantities which have different dimension. which have different dimension. See, if you try to look at the 24th June second shift, we got same question, but the question was identify the physical quantity which have same dimension. Here it is different dimension. See, concepts and questions are being repeated. So make sure that you cover entire previous year questions so that majority of them gets covered and there's a good chance that you can score high. So the different dimension. So the wave number, option A, wave number, even this option was present in 24th second shift. If you can look at the video that was done yesterday. So wave number, meter inverse. Rydberg constant is also meter inverse. Stress. Stress is nothing but force by area, right? What is coefficient of elasticity? See, where do we get coefficient of elasticity? Y is equal to E strain, right? E strain. So units of stress is equal to E strain, right? So stress is equal to Y strain. You can write it either way. So the coefficient of elasticity, E. What are the units of strain? No units. So coefficients of elasticity units will be coefficient of stress. So what are the units of stress again? F by stress is equal to F by A. So again same units. This curiosity and magnetization will also have same units. So let us try to look at option D first. Specific heat, joule per kg Kelvin. Units of specific heat capacity. What are units of latent heat? Joule per kg. Okay. See, if it is just heat capacity, we won't get kg here, and even they will have, sorry, if it is some sort of, okay, if it is just heat capacity, we won't be getting kg here, but it is specific heat capacity, it get kg here. But for heat capacity, we have Kelvin as well. So option D is the right answer, as we have different units. So the question is identify the pair of physical quantities that have different units. Even for option C, the magnetization and the coercivity have these same units. If you try to get back to the magnetization chapter, they form or they have the similar relation, so they have same units. So the D is the only option where we have different units. So people watching online, so try to share your answer and get back to me if you have any queries. So we are trying to discuss the fifth question, right? Yes. So the question says that a projectile is projected with a velocity of 25 meters at an angle of theta with horizontal, okay? After t seconds, its inclination with horizontal becomes 0. If r represents the horizontal range of the projectile, the value of theta will be dash. Use g is equal to 10 meter per second square. Okay, let's try to see what is given. See, a projectile is projected with an angle theta. So its path will be something this way, right? So the question says that projectile is projected with a velocity of 25 meters per second at an angle of theta with horizontal. After t seconds, its inclination with horizontal. After t seconds, its inclination with horizontal becomes 0. What does this statement mean? It means that the inclination of the velocity vector becomes 0. When does the inclination become 0? When the particle reaches its maximum height. So whenever a particle reaches its maximum height, its inclination with the horizontal becomes 0. So if you try to convert this line into a mathematical form, it says that the particle has reached its maximum height after t seconds. Okay. So it is projected with a velocity of 25 meters per second. It is projected with a velocity of 25 meters per second. So and it takes time t. So it takes time t. After time t, it will be at it reaches its maximum height. So what is it being asked? He is asking the value of theta. He is asking the value of theta. Range given R. Range is said that R represents the horizontal range. So what all formulas do we have? So for time of ascent, Ta is equal to u, let us consider it as u, okay, u sine theta by g, right? Time of ascent is given as t, okay. So first equation. So what do we know? What is the formula of range? U 2u square. Okay, let's write bit down. Two u square sine theta cos theta by g, okay, which becomes as u square sine theta by g. So here we are supposed to find the theta. So let's try to write u in terms of t from equation 1. U is equal to gt by sine theta, right? U is equal to gt by sine theta, and substitute u here. What do we get? 2 sine theta cos theta by g into u square, right? gt by sine theta square, g square t square by sine theta square, right? We substituted u is equal to, we substituted u square with u. So what do we get? Sine square sine g square, okay. So r is equal to 2 cos theta gt square by sine theta, right? So g is equal to 10, 20 cot theta t square. 20 cot theta t square is equal to r. So cot theta is equal to 20 t square by r. Theta is equal to cot inverse 20 t square by r. So come on, people watching online, do share if you have any doubts. Get back to me if you have any difficulty. Okay, these questions are being repeated and concepts are being repeated. Okay, sorry. Here, small mistake. C cot theta is equal to r by 20 t square. So r by so cot inverse is equal to r by 20 t square. So theta is equal to r by 20 cot inverse r by 20 t square. I guess we have d, right? We have r by 20 t square. Okay, see, option D is correct. Come on, let's go to next question. Okay, let's go to next question. So the question says that a block of mass 10 kg starts sliding on a surface with initial velocity of 9 meter per second. The coefficient of friction between surface and the block is 0.5. The distance covered by the block before coming to rest is dash. See, it's a straightforward question from kinematics. Mass given, mass 10 kg, initial velocity u 9.8. The coefficient of friction between them is 0.5. The distance covered by the block s before coming to rest, final velocity 0. See, mass 10 kg, initial velocity 9.8 meters per second square, coefficient of friction 0.5. It is come to rest, which means that final velocity will be 0. So we have four variables. And distance is being asked. So what all equations do we have so that we can find them? Come on, people watching online. So what all equations do we have? See, first let's try to draw the free body diagram. Okay, a mass m, forces acting are friction, initial velocity 9.8 meters per second. Okay, first let us try to find the acceleration. Acceleration is equal to F by m. What is F? Mu, friction force, right? Mu n is equal to mg. Okay, g is taken as 9.8, so mu is 0.5. 1 by 2 goes cancelled. 1 by 2, 9.8, 4.9. So the acceleration due to gravity, or the acceleration of the block is 4.9 minus 4.9. If we want to say it very strictly, it is not acceleration, it is a deceleration. acceleration in this direction, deceleration in that direction. Okay, so we need to find s. So from the equation, v square minus u square is equal to 2as. We can find, right? So what is the final velocity? 0. What is the initial velocity? 0.25. 0.5 whole square, 0.25. So 2 times acceleration minus 4.9 s, right? So what is the distance that you get? Sorry, this is initial velocity is 9.8. Initial velocity 9.8. Right, this is initial velocity. This is coefficient of friction. Okay, so 9.8 whole square by, so we get s as 9.8, right? So the option B. This is straightforward question. So hi Nani, I'm fine, right? So come on Nani, try to solve the question. The concepts are being repeated, so there is a very good chance that in next session for JEE mains you may get similar concept. So this is given data. So this is given data. First we found acceleration. Next we substituted back in this equation. We got s is equal to 9.8, right? So come on, let's move to next question. So a boy ties a stone of mass 100 grams at the end of a 2-meter long string, okay, and whirls it around in a horizontal plane. The string can withstand the maximum tension of 80 Newton. If the maximum speed with which the stone can revolve is k by pi revolution per minute, the value of string is massless and unstretched. Okay, right. So he is trying to ask the speed with which the stone whirls or rotates. Okay, so the question: boy ties 100 grams mass at the end of 2-meter long. Two-meter long, 100 grams. So maximum tens, T maximum 80 newtons. (100 grams mass, 2-meter long, maximum tension of 80 Newton. Okay, so he's asking the maximum speed. So what is T max? mv square by r, m r omega square, right? So try to find omega from here. Omega is equal to 80 by mr mass 100 grams, 0.1 kg into 2 whole power half, right? So it will be like 20. Okay, 800 by 2, 400 root 420. So omega we got 20 radians per second. The question is in revolutions per minute, omega is equal to 2 pi n by 60, right? So he's asking in terms of revolution per minute. So n is equal to 60 omega by 2 pi. So 60 into 20 by 2 pi. This is 600 pi, right? So the question is, so he's trying to ask k by pi and the value of k. So we got k by pi as 600 by pi, right? 600 by pi and the value of k is 600, right? Hope you are getting it. Okay. See, nothing, we had just, this is a given part, this is a given part, maximum tension, direct formula mv square by r or mr omega square. So from this we found omega, then omega is equal to 2 pi n by 60, n is being asked. So n is nothing but 60 omega by 2 pi, and n we got as 600 pi. It is asked in terms of k by pi. So k is nothing but 600, okay? Right. Let's move to next question. So the question says that a vertical electric field of magnitude 4 into 10 power 4 into 10 power 9, 4.9 into 10 power 5 Newton per Coulomb just prevents a water droplet of mass 0.1 grams, okay, from falling. The value of charge on the droplet will be given. See, this is, where can you find this? This is Mulliken's oil drop experiment. Like, we can find this data or this kind of stuff or process in the Mulliken oil drop experiment, okay? So here it is being asked a water droplet of mass 0.1 grams. So the forces acting on water droplet mg and the oil drop EQ. See, as it prevents, the net force should be 0, right? So that's what we are trying to do. So the value of E 4.9 to 10 power 5. So he's asking what is the charge. He's asking what is Q. So EQ is equal to mg. So what is Q? Straightforward question. Mass 0.1 grams 10 power minus 4 in terms of kg, okay? G 9.8. mg by E 4.9 into 10 power 5. Right? So what do we get? 2 into 10 power minus 9 coulombs. 2 into 10 power minus 9 coulombs. So straightforward question, straight answer. Okay. Okay, let me not use yellow color. Okay, let me use some other color. So okay, let me explain you again. I guess it's not visible, right? See, okay, mg equal to EQ. Okay, I'm just trying to repeat. Two into 10 power minus 9 coulomb. Okay, come on. Hope it's clear now. So option B, 4.9 given, 0.1 given. Okay, chala, let's go to next question. So, right, a particle experiences a variable force of F is equal to 4x along I cap, 3y square along j cap in horizontal plane xy. Assume the distance in meters and force in Newton. The particle moves from point 1.1, 2 to 2, 3 in the plane. The kinetic energy changes by. See here, force is varying. Force is not constant. It is varying along x-axis as 4x and along y-axis as 3x square. Sorry, 3y square. And it moves from point 1, 2 to 2, 3. So what is the work done? See, what is kinetic energy? See, work done is equal to change in kinetic energy, right? From law of conservation of energy, work done can be written as delta Ke, right? So we will try to apply this formula here. What is work done? F bar dot S bar is equal to delta Ke. See here, F bar is varying and S is from 1, 2 to 2, 3. So let us try to let us integrate F bar dot ds is equal to work done is equal to change in kinetic energy. Let's try to do this. So F bar right, hope this is correct. 4x plus 3y square, right, from 1, 2 to 2, 3. So integral F bar dot dr bar is equal to F bar dot dr. So 4x I cap plus 3y square j cap into dr bar dx I cap plus dy j cap. Okay. See 4x I cap into dy j cap. I dot j 0 because cos theta is equal to 0, cos 90 will be 0. So the I ranges from 1 to 2, this ranges from 2 to 3. So what do we get? 2, 4 minus 1, right, plus 27 minus 8. Hope this is correct. $25, right? Right. So the work done or change in kinetic energy will be equal to 25. Okay, come on. Hello. Hi, everyone. So, try to share if you have any doubts, and because the concepts are being repeated like anything, so make sure that. So, 25 joules. Okay. Ninth question. Done. Chalo. See, the 10th question says that the approximate height from the surface of Earth at which weight of the body becomes one third of its weight on the surface of Earth. So, what is weight? Weight is equal to mg, right? So, here it is said that weight becomes one third. So, mass is nothing but matter. It will not change wherever you go. So, mass remains same throughout the universe. So, the only thing that can change is g. So, the weight becomes one third, means the acceleration due to gravity becomes, it gets reduced by its one third. So the new acceleration due to gravity is equal to g by 3. So what do we know? G is equal to gm by r square, right? Okay. The relation between capital G. So G always remains constant. Mass of Earth always remains constant wherever you go. The only thing is distance from which? From the surface of Earth. So that is being changed. So let us try to equate nu r dash. So g by 3 is equal to gm by r dash r2 square, right? Let's try to find what r2 is. R2 is equal to under root of 3gm by small g, right? What is g? G capital M by r square. So what do we get? R2 is equal to under root 3 R1 square. So R2 is equal to root 3 R1. So the question is approximate height. So R2 is equal to R1 plus 0.7 R1, 0.732, right? 1 plus 0.73, 1.732. Root 3 is equal to 1.732. So the height away from the surface of the Earth is 0.73 R1. So 0.73 R1. What is this R1? 6,400 kilometers. So if you try to solve this, you get as 4685, I guess. 4685. 4685, right? So the extra distance that is away from the surface of the Earth is equal to 4685 because g got reduced. See, g, the new g is g by 3. We just try to equate the old g and new g, and we found R2. R2 is equal to root 3 times R1. Root 3 is nothing but 1 plus 0.732. So this is the extra height, right? So that is 4685. Extra height that we need to travel away from the surface of the Earth, so that the acceleration due to gravity g becomes g by 3, right? Come on, let's move to next question. A resistance of 40 ohms is connected to a source of alternating current rated 220 volts, 50 hertz. Find the time taken by the current to change from its maximum value to RMS. Okay, this is basic fundamental question. You don't need all those values as well. We just need the value of frequency. See, if you try to look at the notation of IRMS, this is I naught. This is something as IRMS. That is I naught by root 2. Right? IRMS. So it makes an angle of 45. Okay? Right? So the question is the time taken by the current to change from its maximum value to RMS. Nothing but the time taken to cover this 45 degrees if you try to rotate, if you try to represent in the form of circle. So the omega given is equal to 2 pi into frequency, right? Omega is equal to 100 pi. Okay, see, there are different ways of solving the problem. I found this as straight method, so I'm picking up. You can do it from other methods as well. So omega is equal to 100 pi radians per second. So the time taken to travel 45 degrees. See, to travel from I naught to IRMS, we need to cover 45 degrees, right? The omega we got as 100 pi. So the time taken will be pi by 4 by 100 pi. We get it as 1 by 400 seconds. That is 2.5 millisecond. I guess option A. So we just try to represent I naught and IRMS on a circle notation, and we got IRMS at 45 degrees. We all know this. See, from omega, that is at 50 hertz, we could able to find the angular velocity, and we got 100 pi. Okay, so 100 pi radians per second, and time taken to travel 45 degrees, because we are trying to change from I naught to IRMS. Okay, we are trying to change from I naught to IRMS. So the time taken pi by 400, you get 2.5 milliseconds. Hope this is clear. So the next question. The equation of two waves are given by these y1 and y2. Okay, these waves are simultaneously passing through a string. Okay, the amplitude of resultant that is being asked. So how do you look at it? How do you solve it? See, generally the resultant amplitude, you have formula as such: under root of a1 square plus a2 square plus 2 a1 a2 cos phi, where phi is the phase difference, right? So we know a1, we know a2 from the standard equation, right? So how do you find this cos pi? See, from the standard notation that we know, this is standard notation of wave equation, right? So we have amplitude here. Now we are supposed to find that phase difference. Once we know the phase difference, we are done, because the amplitude of resultant wave is being asked. So how do you find this phase difference. Phase difference phi is equal to 2 pi lambda into 1.5, right? So we get it as 3 pi. So finally we got the phase difference as 3 pi, and if you substitute it in resultant, we get what is A1? 25 plus 9. What is cos 3 pi minus, right? Cos 3 pi minus 1. A1, 5 3 15. So what do you get? 34 minus 15, right? So I guess we had somewhere wrong. Okay, let me check. Sorry, we have 2 as well. 2, we missed this 2. 30. So the resultant amplitude is 2 centimeters. See, from the standard wave equation, we got to know this is amplitude, and we found the phi, and we substituted back in this resultant equation, and we found the resultant, and we got it as 2, right? Next question. A plane electromagnetic wave travels in a medium of relative permeability 1.61, relative permittivity 6.44. If magnitude of magnetic intensity is 4.5 into 10 power minus 2 at a point, what will be the approximate magnitude of electric field intensity at that point? Given permeability of free space and speed of vacuum is 3 into 10 power 8. See, what is electromagnetic wave? Electromagnetic wave is a combination of electric and magnetic field which are perpendicular to each other. They propagate perpendicularly to each other. Here it is said that the intensity of magnetic intensity is given, and he is trying to ask the electric field intensity at that given point. And they gave properties of relative permeability and relative permittivity. So this is straightforward direct formula based question. So if you try to look at the question given, first let us try to find the speed of light in medium. Cm is equal to C by under root mu r epsilon r. Okay. C by under root mu r epsilon r. What all do we have? 1.61, 6.44, right? So 3 into 10 power 8. 6.44. 1.62, I guess. 6.44, 1.61, right? Okay. Right. We got speed of light in medium. Okay. So we'll be getting something as 9.32 into 10 power 7 meters per second. Okay. Now electric field in that medium. Straight formula from electromagnetic waves, B into C in that medium. So B given 4.5 into 10 power minus 2 into mu naught into Cm. So from the C, here permeability given, here permeability given, permittivity given, magnetic field intensity B given, mu naught given, right? So straight speed of light, this is also given. So straight substitute them, you will get the answer as, actually we don't have options here, so we will be getting as 5.26 volt per meter. As this option is not present, 5.26, we don't have any 5.26, so none of the above. So everyone will get bonus mark here. So bonus mark will be given for all aspirants because there is no answer here. So we are trying to expect a bonus mark. See, the key will be checked and reviewed. Okay. So this question, there is no answer in the given options. So let's see what happens at the end. Okay. See, the next question says that choose the correct option from the following options given below, right? In ground state, Rutherford's model, electrons are in stable equilibrium, while in Thomson's model, electrons always experience net force. See, in Rutherford model, electrons move around nucleus. The concept of nucleus was invented in Rutherford model. So the electrons are never in stable equilibrium. Never in stable equilibrium. Next, the atom has nearly continuous mass distribution in Rutherford model. This is wrong, because same nucleus concept was discovered and it is said that the majority or maximum or the entire mass is of nucleus. So here in Rutherford model, the continuous mass distribution does not take place. In Thomson's model, it takes place. So the statements are given in opposite manner. So even this is wrong. Classical atom based on Rutherford's model is doomed to collapse. Yes, because when electron keeps rotating around the nucleus, it should slowly lose its energy and finally fall into nucleus and it should get destroyed. So that is the reason that's where the Rutherford's atomic model fails to explain. That's what Rutherford atomic model fails to explain. So this is correct. According to Rutherford model, it is doomed to collapse. Okay, correct. The positively charged, option D, the positively charged part of the atom possesses most of the mass in Rutherford model but not in Thomson's model. It is again wrong. The positively charged particle, because nucleus got invented, so the mass is not just due to protons but also due to nucleus, right? Even in Thomson's model as well, it is said that the mass is also due to protons. So here it is said that a positively charged particle of the atom possesses most of the mass in Rutherford's model, but not in Thomson's model. Even in Thomson's model, the mass is due to protons only. Okay, so option C is correct. Come on, next question. The nucleus is having a mass number of 220 and its binding energy per nucleon is 5.6 million electron volts. It splits into two fragments, B and C, of mass numbers 105 and 115. The binding energy of nucleons in B and C is 6.4 million electron volts per nucleon. The energy Q released per fission will be. C, fission. 1 splits into 2, right? 1 splits into 2. So here it is given as 5.6 million electron volts. Here it is given as 6.4 per both. So if we try to remove the initial energy from final energy, we get the net total energy that's released. So that's a straightforward basic mathematical aptitude question. So how do you find the total energy in case 2? Finally, 6.4 into, this is 6.4 million electron volt per nucleon, right? So 6.4, what are the total number of nucleons? 105 plus 115. How much do you get? 220, right? Sum of 105 and 115. 110 plus 110, approximately 220, right? 105 plus 115. Minus 5.6 into number of nucleons. What does mass number represent? Number of nucleons, 220. 5.6 million electron volts per nucleon. So we get it as 176. If you try to, so option D, correct, straight question. See the total energy final minus total energy initial, we get net energy that is released due to fission. 6.4 into 105, 6.4 into 105 plus 115, 220 minus, we get that. Okay, straight question. So the baseband signal of 3.5 gigahertz frequency using amplitude modulation method. What should be the minimum size of antenna required to transmit the modulated signal? So this question is from communication. So this is again a basic fundamental formula question. What do we have? Lambda C. See, antenna size is equal to, see, size of antenna required, right? Antenna size is equal to lambda C by 4. So once we get lambda and if we divide it by 4, we are done. So how do you find lambda C? C by Fc, frequency. Okay, what is C? Speed of light, 3 into 10 power 8. So what is frequency? 3.5 gigahertz. 3.5 into 10 power 9. So how much do you get? 3 by 35 meters. Is this the answer? No. And it should be divided by 4 again. Then you will get, so size of antenna is equal to 3 into 1000, we are mm, we will get in terms of mm. So we get it as 21.4 mm. So we need to take care of units also. See, we have meters, 21.4 meter, 21.4 mm. So right from this first step, we need to take care of meters, and it's a straight formula, direct question. So we get lambda C, we get antenna, we get size, right? So Mr. Rohan, the analysis of paper that happened today will be discussed after a while once we get authentic information, so no worries. So try to focus on things that is being happened because the questions are getting repeated. Even in yesterday's EAMCET paper, the questions from JEE mains are repeated. So that is the reason we are trying to cover the JEE exams that occurred in June. Okay, so it increases your chance of getting high score. So focus. Now let's go to next question. A Carnot engine whose heat sinks at 27 degrees. Okay. A Carnot engine. 27, 300 Kelvin. 27 plus 273, 300. Has efficiency of 1 by 4. Okay. So how do you write efficiency 1 minus T2 by T1, right? Is equal to T2 by T1 is equal to 3 by 4, right? So what is T1? T1 is equal to 4 by 3 T2. So what is T2? 300. So we get it as 400. By how many degrees should the temperature of source be changed? The efficiency is increased by 100% of its original. So what do you mean by increase in efficiency by 100%? By how many degrees should the temperature of the source be changed to increase the efficiency by 100%? So what does it mean? Increasing the efficiency by 100%. See, increasing the efficiency by 100% is nothing but final minus initial by initial should be is equal to 1. Which means that the efficiency final is equal to 2 times the efficiency initial. Okay, see, nothing but final minus initial by initial is equal to 1. What do we get from here? Final is equal to initial plus initial is equal to 2 initial. So the final efficiency will be is equal to 2 times the initial efficiency, which means 100% into 100. Which means that efficiency is getting doubled. So if you double the efficiency, what should be the T1? That's what he's trying to ask. So what was initial efficiency? It was 1 by 4, right? Now it's got doubled. 1 by 2 is equal to 1 minus T2, 300 by T1. We need to find it. So we get T1 as 600. So by how many degrees should the temperature of the source be changed? From 400, it needs to be changed to 600, which means that delta T1 is equal to 200. Right? So increases by 200. Straight question. Right? Next question. A parallel capacitor is formed by two plates of area, each of area 35 centimeter square, separated by dash mm. I guess it is 1 mm. Let me check. Question 18, right? Separated by 1 mm. The material of dielectric strength 3.6 into 10 power 7 volt per meter is filled between the plates. If the maximum charge that can be stored on the capacitor without causing any dielectric breakdown is 7 into 10 power minus 6 coulombs, the value of dielectric constant of the material is dash. See, this is again the basic fundamental question. What do we know? See, we know that Q is equal to CV, right? From basic fundamentals. Okay? We know that C is equal to epsilon naught K A V by D. Sorry, K A by D, sorry. The formula for capacitance. So we are just replace C is equal to this one. Q is equal to epsilon naught K A epsilon naught K A V by D. Let's try to write as E. nothing but electric strength. So we have all given. Just substitute it. K is equal to Q by epsilon naught K AE Q. What is this Q? What is this Q? We have, right? The maximum charge that can be stored, 7 into 10 power minus 6. What is this epsilon naught? From here you can find epsilon naught. We get as, I'm trying to write the direct final value, 8.85. These are basic substitutions, okay? 10 power minus 12. Epsilon naught. What is area? 30 pi square. Pi 10 power minus 4. We are converting it into meters. Okay. Next, E, electric strength, dielectric strength. It is in SI unit. 3.6 into 10 power 7. Right? So what do we get? We get value of K as 2.33. See, there is nothing much logic behind it. We know this. Q is equal to CV. Right? Capacitance formula we know. Replace capacitance in Q is equal to CV. What is this E? Nothing but V by D, dielectric strength, V by D, volt per meter. So just solve for K, we get answer. Next, the magnetic field at the center of the coil of radius is R due to current I. Okay. The magnetic field along the axis at a distance of r by 2 from the center is. Once again, basic direct question. See, magnetic field along in a loop carrying current I is at the center is B is mu naught I by 2r. So if you want to find along the axis which is at a distance x, we have direct standard notation, that is B is equal to mu naught I r square by 2 r square plus x square whole power 3 by 2. So what is this x? At a distance of r by 2 from center. So replace x by r by 2. R by 2 whole square, r square by 4. R square by 4 plus r square. How much do you get? 5r square by 4. Right? Whole power 3 by 2. I am taking r out. So mu naught I r square by 2 out, 2 cube, r out, r 5 power 3 by 2, r goes off, and finally we will be left with we will be having B along the axis is equal to B into 2 by root 5 whole cube, because mu naught I by 2r is B. So if you substitute back, finally we get this as, so 2 by root 5 whole cube B. So this is the option that we get. Okay. So basically, this is the standard notation we know. This is derived from this along the axis. So substitute x is equal to r by 2, you get the answer. Next. So two metallic blocks M1 and M2 of same area of cross section are connected to each other as shown. If the thermal conductivity of M2 is K and M1 will be dash. See, heat flows this way, right? So the heat flowing will be same. So Q is equal to delta T by L by Ka. Okay. Let us apply this equation to both sets. So Q is same throughout. Delta T 80 minus 100. Okay, let us 100. Okay, you can take it either way. The negative symbol gets cancelled. Length 16. 16 cross section area, same area of cross section. So A gets cancelled. This is K1. We need to find K1 is equal to 80 difference by 8 by K2. Okay. Sorry, this is K. 8 by K. So we need to find K1. Force 4 ones are 4 twos are 2 eights are, right? So K1 is equal to 8K. Simply Q is equal to delta T by L by Ka. Q flows from higher temperature to lower temperature. So Q is equal to delta T by L by K, where this is the resistance. So we took delta Q across first block, delta Q across second block, as Q is Q traveling is same. This is analogous to V equal to IR. I is equal to V by R. If you try to compare it. So when connected in series, same current passes through, right? In the similar fashion here, same heat passes and we can directly solve it. So it is 8K. Next, let's go to section B. So the first question says that 0.056 kg of neutron is enclosed in a vessel at a temperature of 127 degrees. The amount of heat required to double the speed of its molecule. See, temperature is nothing but the temperature of, according to kinetic theory of gases, average temperature is nothing but or proportional to average kinetic energy of the gas molecules. Okay, so V square is proportional to T, V proportional to root T. Okay, so if you want to double the speed, what will happen? V goes to 2V, temperature goes to 4T. If you double V, temperature becomes 4 times temperature. So initial temperature 127 plus 273, 400 Kelvin. Final temperature 4 times 1600 Kelvin. Okay, from this. What is delta T? 1200 Kelvin, right? See, what is the amount of heat required? Q is equal to N CV delta T. So heat supplied is equal to change in internal energy plus work done. Work done is 0. So enclosed in a vessel, so no work done. So Q is equal to delta U plus work done 0. Q is equal to delta U is equal to NCV delta T. So what is N? Given weight by molecular weight. Given weight by molecular weight of nitrogen 28. For a nitrogen, CV is equal to 5 by 2 R. Delta D 1200. So R is given as 2. So how much do you get? So how much do you get? Q is equal to 12,000 12 kilocalorie. Kilocalorie, it will be 12. Okay? Right? Simple. V square is proportional to T. So V doubles, temperature becomes 4 times. So temperature initially it was 400, from T is equal to 127. It became 4 times, delta T is 1200. Q is equal to delta U, change in internal energy from first law of thermodynamics. Heat supplied is equal to change in internal energy plus work done. Okay? So work done is 0. So change in internal energy is equal to NCV delta T. CV I can write as 5 by 2 R for diatomic gas, that is nitrogen. R we got 2, and if you substitute we get the answer. Next, two identical thin biconvex lenses of focal length 15 centimeter and refractive index 1.5 are in contact with each other. The space between the lenses is filled with a liquid of refractive index 1.25. The focal length of combination is dash. See if you try to represent it in the form of diagram. Biconvex lens, two identical thin biconvex lens of focal length 15 centimeter. So first we are trying to talk about lenses. Okay, F is equal to 15 centimeter and refractive index mu is equal to 1.5. Okay, are in contact with each other. Okay, first let us try to find the radius of curvature. The radius of curvature is focal length. It will be equal to focal length. If you can find, you can even find it from the lens maker's formula. Okay, so now let us try to find out the F1 for glass equivalent. Okay, that is R by 2 mu minus 1. I am trying to write this straight notation. You can derive it as well. So we cannot derive the entire formula while solving the question. So this is a standard notation that we generally follow. So R by 2 into 1.5 minus 1, it equal to R again. Okay. In the similar fashion, if you try to look for glass, F2 is equal to minus R, why minus? Because diverging, 2 into mu minus 1. So we get it as minus 30 centimeters roughly. Okay, this will be 2 by 15, right? So what is F equivalent? So what is F equivalent? 2 by 15. 2 by 15 minus 1 by 30 is equal to 3 by 30. F equivalent is equal to 10 centimeters. Okay. So we have directly applied formulas F1, F2, and we found the F equivalent. So there is nothing much logic behind it, just straight formula. if we can draw the, if we can try to draw the peak or the physical representation of the lens, you are done. So third question. The question says that a transistor is used in common emitter mode in an amplifier circuit. When a signal of 10 millivolts is added to the base emitter voltage, the base current changes by 10 microamps and the collector current changes by 5.5, 1.5 milliamps. By 1.5 milliamps. The load resistance is 5 kilo ohms. The voltage gain in the transistor will be. See, this is once again a straight formula question. Just substitute the values, you are done. See, given VBE 10 millivolts, okay? 10 millivolts. Next, IB 10 microamperes, right? Next, IC, it is again 1.5 microamps, right? Next, RL 5 kilo ohms. C, VBE given 10 millivolts, IB 10 microamps, IC 1.5, load resistance 5 kilo ohms given. Now the voltage gain in the transistor will be, which is equal to how do you find this beta? First let us try to find this Ri. Ri is equal to delta VB by delta IB. Okay, so we get it as delta VB. What is this delta VB? 10, right? 10 millivolts. Okay, 10 millivolts by 10 microamps. So 10 power minus 3 goes up, it gives us 1000. So we get as 10 ohms. In the similar fashion, beta, how much do you get beta? How much do you get beta? It has delta IC by delta IB. You get it as 150. Ri you have 1000, 10 into 10 power 3. 10 power 3 by 150, right? So substitute here. You get as 5000 by R0. What is this R0? Load 5 kilo ohms. Ri 1000 into beta 150. You get as 750. See, straight question. Given data, we are supposed to find the voltage gain in the transistor. We have straight notations for it. R0 by Ri into beta, where Ri we need to find from emitter, common emitter. Next, beta we need to find by ICs. Okay, so by substituting these two formulas in above standard formula, we'll get as 750. Okay, right. So question 4 says that as shown in the figure, an inductor of inductance 200 microhenry connected to an AC source of EMF 220 volts and frequency, what is this frequency? Okay, let me check. Frequency of 50 hertz. 50 hertz. The instantaneous voltage across the instantaneous voltage of the source is 0 volts when the peak value of the current is root A by pi amps. So what is the value of A is dash. So what is the value of A? See, the current and EMF, or the current and the potential has a phase difference of 90 degrees, right? So here it is said that the instantaneous voltage will be 0. So obviously the I will be at its peak value. Okay, so V0 I has its peak value at this instant. So what is that peak value of I0? That is so the peak value of current will be V0 by XL, right? What is XL? The resistance due to inductor. So what is V0? 220 root 2. Generally it is given as RMS. So this is given will be RMS 1. So we need to convert it into peak 1. So what is XL? 2 pi omega into L. So substitute it. Straight question we get as root 242 by pi A. So the answer of A is 242. See, nothing, straight. Once you are aware that at this instant, when the voltage is 0, I will be at its peak value because the phase difference between them is 90 degrees. So from this formula we can directly find. There is nothing much logic in it, straight question. Sorry. So when light of frequency twice the threshold frequency is incident on a metal plate, the maximum velocity of emitted electron. See this question, similar question repeated in 24th June first shift. See the pattern of questions are being repeated. Same JEE means we got this question in the morning and afternoon similar question we got. If you try to look at the video that we had done yesterday, you can find it. 24th June second shift, you can find same question, similar question. 80% same. 80% same question. See, in the same session only we are getting repeated questions. So you need to be very good with the concept of the previous year questions to increase your chances of high score. So when light of frequency twice the threshold frequency is incident on metal plate, the maximum velocity of emitted electron is V1. When the frequency of incident radiation is increased to 5 times the threshold value, the maximum velocity of emitted electrons will be V2. If V2 is equal to xV1, the value of x will be. See, straight question. Energy H mu is equal to H mu threshold plus K. See, the energy supplied will be used to overcome the threshold energy first and remaining will be converted into kinetic energy. So first it is said that the maximum velocity is V1. Okay. So V threshold. So what is being asked? Let me check once again. When the light of frequency twice the threshold frequency. Okay. Okay. The maximum velocity emitted is V1. Okay. Here it is said that half m V1 square. When frequency gets doubled, the maximum energy is half m V1 square. Okay. If we try to increase to 5 times the threshold value, H 5 mu. The maximum value of will be dash. Direct divide 1 and 2. 2 by 5 is equal to V1 square by V2 square. Right? So, sorry, here we will be having H mu is equal to K, right? So what do we get here? K is equal to twice the threshold, okay? So K is equal to H mu threshold, okay? So what is now? Threshold plus K, right? K2 is equal to 4H mu threshold. So Ke1 by Ke2 is equal to V1 square by V2 square is equal to 1 by 4. So V2 1 by 4. V2 is equal to 4 V1. Sorry, 2 V1. 2 V1. Okay, that's how we will be solving the problem. So straight question, H mu plus kinetic energy, H mu H. See, threshold frequency gets doubled. Here, same threshold 5 times. So we will get getting kinetic energy as H mu threshold. Second kinetic energy is 4 times H mu threshold. So ratio of those two, we will be getting the velocities. Okay. Chalo. So the question 7. So these are basic questions. From the top of a tower, a ball is thrown vertically upward, which reaches the ground in question missing again. So let's try to look at the 7th question. So Mr. Nitish sir, private college करने के साथ JEE में 2023 दे सकते हैं Mr. Nitish Patel. You can give exam, but you need to be focused enough so that you can get good score. So we have 4 questions left. So we will try to do the remaining questions in next session. Okay. So we have completely 4 questions left, right? 7, 8, 9, 10. We have 4 questions left, and we will be doing these 4 questions in next session. So thank you. So we are doing this series since a week. We have covered first year formulas and their important concepts, second year formulas and their important concepts. So go through them. Definitely you will find them useful for your competitive exams. And we have started a new series of doing previous session 1 JEE mains question. So we are done. We have completed yesterday 24th first shift, 24th yesterday second shift, and today we are doing 24th second shift. So we have 4 questions left tomorrow finally. So we will continue it in the next session. So thank you all for being patient. So do like, share the session so that many get benefited, and we are trying to do it for free. So kindly encourage us. Thank you. And the following, so we will be having the EAMCET paper analysis, and this series continues. Thank you.